This is the first in a series of videos on innovative energy solutions in the condos and apartment buildings.
Hi, I'm Sherif West from Mann Engineering. We're here at a construction site where we're doing one of our new projects for a boiler retrofit. And we apologize for any noise in the background. We're still under construction. Today we wanted to talk about boiler retrofits in general. And this particular project, we're doing an innovative design at the site. Wes, can you tell us more about what we're doing at the site?
Yeah, so what we're doing here is we originally commissioned to replace all 6 of their boilers here. As you can see, there's 3 hydronic loops in this building. The first one is this heat pump loop right here, which serves the in-suite heat pumps for the building. And that's a low temperature loop, meaning between 70 to 90 degrees Fahrenheit. And the loop back there is the primary heating loop. That's a high temperature loop, which is what we would consider to be 140 degrees Fahrenheit or above. And that serves the makeup air, perimeter heating, pool heating, ramp heating, things like that. And then over behind me over there on the mezzanine level is the domestic hot water system, which obviously serves the domestic hot water. Now those 3 loops are separated, and they started off separated. And each system has 2 boilers. That's for redundancy purposes. And what we've suggested to the client, and they've agreed to, is to integrate all 3 hydronic loops into one loop, essentially. And this new loop would just operate off of 2 new boilers. So instead of having to replace all 6 boilers, now we're just having to replace 2 boilers, slightly larger boilers than what was there before, but still only 2 boilers. And this is a large reduction in capital costs to the client and also results in fairly significant energy savings. The reason why that these loops were initially separated is because the perimeter heating loop, called the primary loop, which service again the ramp heating and the makeup air, is what's considered a high temperature loop. Temperatures in excess of 140 degrees Fahrenheit. Meanwhile, the heat pump loop generally is between 70 and 90 degrees Fahrenheit. And that's the reason why these loops are separated hydronically. But by using a simple injection system where we take heat from the high temperature loop and inject it into the low temperature loop, we can combine the systems and only operate off of 2 boilers as opposed to 6. What we're doing with the domestic hot water system is because you have to keep a separation between potable and unpotable water. Potable water means drinking water, so that goes out of your tap. So in order to integrate those 2 systems, we can't have a direct connection. What we do instead is use a heat exchanger.
What do you predict the energy savings of this project?
For the energy savings perspective, we estimate that it's going to be approximately 17 to 25% off of the natural gas consumption for the building. And that's for 2 reasons. One is the inherent increase in efficiency of the new boilers we're putting in compared to the old, inefficient boilers that were initially in there. Because the existing boilers were 60% efficient atmospheric boilers, and we just replaced them with near condensing, 88% efficient boilers. In another episode, we'll go into, and we get asked this a lot, why do we, when's the right time to choose a condensing boiler versus a non-condensing boiler? And it really depends on the application. For this application, because it's a high temperature loop, we've chosen to go with a non-condensing, near condensing boiler instead of a condensing boiler. That is the first part of the energy savings. And then secondly would be the actual integration of the system has inherent increases in efficiency. Whereas before you would have multiple boilers all running at once, now you just have 1 or 2 boilers running at once.
So how are we able to go from 6 boilers to 2 boilers?
So the reason why the existing system has 6 boilers was, as I mentioned, there's 3 hydronic loops, and for redundancy purposes, you'll never see a boiler system that has 1 boiler. They're always going to have 2 boilers in case 1 fails. So that means every loop has to have 2 boilers or more. So by integrating all the systems into one system, we only need 2 boilers. Because if 1 fails, again, the other one can operate. So there's a huge reduction in unneeded redundancy.
How are you able to control the new system?
Okay, yeah, controls is a hugely important factor in this type of job. by integrating the three systems, it's not really possible without a good, proper control strategy and a very effective building automation system. So that is an integral part to this job, to make sure that each of the hydronic loops are operating properly.
And did you have to replace the entire control system in this case, or just make modifications?
In this case, they had an existing building automation system. Since we did have to add a few new pumps and control valves, we had to slightly modify the system, and we upgraded the major hardware, being the control boards, as they were a bit outdated. But most of the wiring and sensors we were able to keep, and that's ended up saving the clients a lot of money.
All right. Thank you guys for coming through the project with us. If you found this information helpful, you can contact us with any questions you have at the link below.